In the previous video, we imported our first character into Unity, set up the sprites, and got everything ready for the actual character implementation. So today, let's get started into the real programming by setting up our character manager. Before we code anything though, we're going to need to take our characters from nothing more than images to active objects in the scene, so we'll need to make prefabs of each one of them that we can spawn in. The thing is though, we have to think ahead before we do this. So we know that our characters may be multi-layer characters, which means there won't simply be one renderer to a character. Also, when we transition character images, we want to add and remove renderers associated with the character, not the character itself. So what we're going to do is want a core object, which will actually be our character, and then some child objects which will render the parts of that character. So let's do that by adding just a regular image to the scene. But this is just a container for the renderers, so we can actually remove the image component attached to it. Now we've just got a rect transform. So scale it up to something that's appropriate for your character. And rename it to a value that you can use as a search string for the specific character, because we're going to be locating each prefab from resources. Now let's add the renderer for our character. So remember, image for sprites, raw image for full textures. Raylene here is a texture imported as multiple sprites, so she has to use an image component, no questions about it. But I've also got another character, a single layer one, that's imported as individual texture files for each emotion. Each texture is imported as a sprite, so technically this one can use either raw or a regular image. But I prefer to use sprites though, that's just my preference. And since we're going to work with multi-layer Raylene first, I'm going to add an image in. Parent the renderer to the character container since it'll be a child. And just scale it to the dimensions of the container. And just like that. Now add the character body sprite to it. And you can hit preserve aspect ratio to help size the character just right during the initial setup, but I'll just leave it off for now. And I want to see this in game view, so I'm just going to switch that over right now. Alright, and with the body of the character parented to the container, we can just scale the container object to scale the images. Although we want to set the anchors of the renderer first to the bounds of the container. So select that renderer and click the anchor image right here. Now we can scale the container the way we want to. So just scale the character to what looks best, or you can always settle for maintain aspect ratio and just make sure they're positioned right. Here I'm scaling it manually and just comparing it to aspect ratio. And as you can see, I've actually got it pretty perfect. So I'll name this renderer the body layer. The name doesn't really matter here, it's just so I know what's what without clicking on it. And now I'm going to duplicate that layer so I can make the renderer for my character's facial expression. And this I'll call the expression layer. Now I just need to swap the body sprite for a facial sprite. And there we are. So this is now a complete multi-layer character. And I can just change the expression without changing the body, except when I change to one of a different angle like this, so that will require me to change the body angle as well. And it all works out when I do that. Now just set the anchors of the character container to match the bounds of its rect transform. That way it adjusts to the game window size. And when we save this object as a prefab, the anchors are going to be saved as well, so literally just by adding it to the scene, it'll automatically adjust itself. Alright, so let's play and check it out. And she adjusted to the full screen quite nicely. But she does look a little rough around the edges, I can see that now. Let me zoom in here. And if I recall correctly, that is not what the original image looked like. This is probably because I'm using point filter mode. Point filter makes edges sharp and is generally used for smaller images. I want to use something that'll kind of blur the edges and give a smooth look on my character. So bilinear should be a good choice for that. Let's just wait for that to apply. And alright, yeah, that looks better. Okay, everything looks fine there. Yeah, those edges are no longer sharp, and that's exactly what I want here, so I think we're good. Now that we've completed the character, it's time to save it as a prefab, something we can call by name and load during gameplay. We're using resources to load, so make sure you place it in the character folder in the resources folder. So drag the character object from the hierarchy to the folder to make a prefab. There we are, and now I have a prefab for Raylene, so I can just delete her from this scene. Now notice how if I drag it into the scene, you can't see it. It's in there, but because it's not attached to the canvas, the UI isn't rendering it. So that means when we add the object to the scene, it needs to be added directly to the UI or parented to an object in it. That would be our character layer panel. And that places her in the UI behind the dialogue and in front of the background, which is exactly what we want. It also maintains her size and anchors, so we can literally drag and drop characters now. But we're not going to be dragging and dropping anything. The way we'll add characters in our scene is via script. More specifically, we'll do this through a character manager class that'll create, control, and maintain every character in our scene. So in our scripts, create a class called character manager. And let's also create a class called character, which will represent any character we create. The reason for this is to give the manager something to associate with a character. It also gives us a way of adding controls to our characters, like transitions and movement. So let's open these up in our script editor and get started. The character class will represent any and all characters that appear in our visual novel, so it needs to have universally applicable values and functions that any character should use. And since our manager will keep a list of characters, I'll make this class serializable so I can view them in the editor. Start and update won't be used, so I can delete those and give our character a name field. The name is what will display when the character speaks. So go to the character manager now. And the manager is going to spawn characters as we need them and contain them within a list so we can easily access their active instances. It's really going to make accessing characters quick and easy, but we need a list and a dictionary to do it. First off though, let's make a static instance of this class so we can access it from any other without any manual variable assignments. And you probably know where I'm going with this, so let's go ahead and create the awake method and assign it in there. So say instance equals this. And now let's remove start and update since we won't need those either. Now since our characters will need to be spawned into the character layer, we need a reference to the panel. I also want to incorporate the Unity Engine UI namespace, so let's go ahead and do that right now. Now I'll reference the character panel's rect transform. It's important to reference that panel since the characters need to be spawned on it in order to be seen and placed in the right depth on the UI. Now we can make our list and dictionary variables. The list will hold every active character instance in the scene, while the dictionary will learn their names and index values within the list. So make the list hold the character class we created. Every time we add a character in the scene, we'll add their character component to this list so we can keep track of them. And now make the dictionary. The dictionary is going to be a string and integer relationship, the string being the name of the character in the scene, while the integer points to its index within the character list. By using a dictionary like this, we won't have to search every character in the list and compare names to return the one we're seeking. We'll just call the name of the one we want and retrieve the index. It's just a quick and easy way of attaining simple access for our list. Let's start off by making a function called getCharacter. Pass in a string for the character name we want to find. And this function's purpose is to return an instance of the desired character if it already exists in the scene. But how do we know if it exists? Simply if an index by that name is already logged in our character dictionary. So if the name we want is in the dictionary, we'll take the integer value paired with that name and get the character from the list at that index. So to do this, we first need a temporary storage integer. Now let's try to find the value of the name we're searching for in the dictionary. You can use try_getValue, which will return a boolean and cast the result to our temporary integer. So if we succeed in finding the title of a character name in our dictionary, we'll automatically get the integer associated with it. If that's true, then we know the character exists, and we just return the character at the retrieved index. On the other hand, what if our dictionary doesn't have the character name? Well, that means the character doesn't exist, and we can't return an active instance of it. What we can do, though, is create one. Let's make an optional Boolean parameter as to whether or not we should create a character if it doesn't exist or not. That way, we'll just get a little flexibility here. Make it optional just by giving it a default value, and I'm going to set mine to true by default. So now where we determine the character doesn't exist, if we're supposed to create one, then that's what we'll do. So let's make a function for creating a character down here. Give it a return value of character, and pass in the name of the character we want to create. So with this return value, once we create the instance, we'll get it immediately for any assignments we want to make to it. So if no character exists, and we're supposed to create one, then call create character, passing in the name. And since the whole purpose of this function is to get the character, we need to make sure we have a return value no matter what path we take. Now head back to the character class, because that's where we're actually going to create the new instances. Make an initialization call below the name by saying public character, then pass in a string parameter which will set the name of the instance. So this lets us just create a new character and pass in some parameters to customize it the moment it's created. This is also where we'll load the prefab and spawn it into the scene. We need to parent the character to the character panel, so we need a reference to the manager since that's where the variable will be stored. We set it up earlier, so we just need to call it by its instance, which is assigned on awake. Now in order to spawn the object, we need to load it from resources. Back in Unity, I just want to confirm the path I stored Raylene's prefab at. And that's just resources characters Raylene. So to load from resources, just say resources.load, followed by the path of the item you want to load. Here's where the format of that name comes in handy. I can just say character and add the character name, and that gives me my prefab automatically. But resources is just going to load it as an object, so we need to cast the prefab as a game object. Now we have the prefab for our character, so we need to spawn it. So let's instantiate the object into the scene. Pass in the character panel as the parent. That way we bring the prefab into the canvas automatically. We'll want a variable to store the container for the character's renderers, so make a hidden rect transform variable. I'll call this the root of the character, and trust me, we're going to want this reference later on. Now assign root as the rect transform of the object we just spawned into the scene, because that object is going to be the container that holds all the renderers. We can also set the name of the character now, and that's just the name variable we passed in at the beginning. And now we need to get the renderers parented to this character. This is going to be a little extra laborious for me since I'm showing you guys how to do both single layer and multi-layer characters, which means I need to collect raw images and images. You only have to get raw images if your characters use textures and not sprites, otherwise you only have to worry about getting the image components, which will simplify your workload. But I'm going to do both since there's something I want to show you guys about raw images that has to do with flipping a character in a way that can't be done with a UI sprite. So I'm going to make an internal class to hold all my renderers. I'll just call this class and simply renderers. This is going to store all my renderers and let me access and change them relatively easily. And of course I need the UI namespace to do this, so let me go ahead and add that up top. Public image, and this will be for a single layer character. I'm not going to use an array or a list here. I'm just going to make 3 image variables, one for the single layer, and one for the multi-layer body, and one for the multi-layer expression. So doing it like this, I can just directly edit any of them by their name. Oh, but I about messed up here. Forgot that my multi-layer character is the one that uses images and not the single layer character. Now initially I'm going to try to get both the raw image and the regular image components from the container's children so I can determine if this new character is a single layer or a multi-layer. Do yourself a favor and determine the type of character you're going to use before coding this out. That way you only have to code for one or the other instead of both like I am. And this boolean here is just to let me know what kind of character it is without me having to check what renderers are there. Again, if you use one or the other and not both, you don't even have to worry about this. So if this is not a single layer character, then check for image components, which will be my body and expression layers. And I know that I named the body renderer body layer, so that's the child object I'll search for to get the body renderer. And same for expression. So transform.find body layer to get the child of that name, and then get the component image that's attached to it. And I can just copy and change the name for my expression renderer. So expression layer and renderers.expression renderer. So now I'll have either the raw image renderer or the multiple sprite renderers. And we don't even have to manually return this character because it's already done on creation. So let's go back to the character manager now. All we have to do to create a character here is say new character and give it the name of the character we're trying to spawn. Now that we've created it, we need to add this character to the list as well as the dictionary so we know that it already exists at a later time. So add the character name to the dictionary, and for the value, make it the current count of the character list since that'll be the valid index after it's added. And now add the character to the list. Then just return that character at the very end. And with that, we're successfully able to retrieve and create characters through our manager. So let's hop back into Unity and try this out for ourselves. We'll just let it compile for a moment. Oh, okay, yeah. My getCharacter function is a void return right now, so I need to set that to character instead. And I have 2 warnings here. Lovely. Okay, let me go check that out. Okay, this one I need to actually assign renderers as new renderers class. And then name. Alright, and just change this variable name to something like character name. That way we're not using the same name that's used as a reference for the object name. And just change the reference down here. Alright, and that clears it up. So now I want to test out our character manager, so I'm going to create a testing script like the one I used for the dialogue system. Put it in my testing folder, which I'm going to delete before building the game. So the cool thing about the setup we have here is we can store characters as variables and not just their game objects. So I can create a character variable to house Raylene once I create her in my scene. Gonna make it public so I can actually see her in the editor. And making her is as easy as saying Raylene equals charactermanager.createCharacter Raylene. Or since getCharacter will create them as well, we could use that too. Just make sure to use Character Manager's instance and not the classic self since we're not using static functions. Pass in the name of the character and that'll create her for us. So now add the Character Manager to an object in the scene, advisably a core object such as the canvas. And there it is, and don't forget to add a reference to the character panel, because we'll definitely need that. Now let's play and watch Raylene appear in our scene. And there she is. The character manager spawned her in, so she's here, and we know the character exists because she's been added to the list. But I see a problem, though. Raylene isn't showing up in our variable, which she should have been assigned there, and apparently she's not in the list either, so something isn't right there. Okay, and this is because the character class is still a mono behavior that isn't actually on an object, so remove that derivation and add GameObject before instantiate down here. So character should not be a mono behavior. And that fixed it. So Raylene is now showing up in our list, there's her root object, and everything looks good. But now that I'm looking at it, I want to see her renderers. So let's go in and allow ourselves to view those renderers. Since I made this a class on its own, I'm going to make it a serializable class. Then I'm going to take the variable and make it public. And you know, while I'm at it, I may as well make the class public too. Alright, now let's play. Okay, and we see renderers. And now it shows her two image components. Raw image is empty because she's not a single layer character. Alright, that's pretty good. So we've got our first character being used in our scene, but before we go, let's add a bit of functionality so you can really get a feel for how convenient the character class really is. One thing all characters should be able to do is talk, so let's add a public function called say to the character class. For this, we only need to pass in what the character is supposed to say, since we obviously know who's going to be saying it. And since the characters will need to speak, we'll want an internal reference to the dialogue system at start as well. Make a private storage variable for it, and then just assign it when the character is first created. So at the very end of our initialization, I'll just say dialog equals dialogsystem.instance. Now back in say, just access the dialog system say function and pass in the speech as well as the character's name. And as simple as that, our characters are now capable of sending text to the dialog system. So back in my testing script, I want Raylene to start talking. I'll just make a string array with stuff for her to say. And an integer to keep track of the dialogue progress. So whenever I press a key here, I just want her to say something from that array. And to do that, I just get the character I want to speak and call her by name by typing Raylene.say. Then she just needs to say whatever text is in there. But if she reaches the end of the dialogue array, then she shouldn't speak anymore. So I'll make sure that I don't have her say anything if that's the case. In fact, if we reach the end, I actually want the dialogue system to close and hide itself. But that capability isn't here yet, so let's go into the dialogue system script and add that ability. Let's go down to the bottom somewhere around here and create a new void function called close. Inside of this function, we first need to stop speaking if anyone is speaking, and then we need to disable the speech panel game object so it's no longer visible. Now once Raylene has reached the end of her dialogue, I'll close the dialogue system with the new function we just created. And now let me give her some things to say. Let's say, hi, my name's Raylene. How about, how are you? And then maybe she'll feign some interest. Oh, really? So let's get started now. Alright, I'm just going to close the dialogue system right now so it comes up automatically. Alright, there we are. So with Raylene.say, she opens the dialogue system and starts speaking. And then at the end, it closes. Alright, congratulations guys, we now have the beginnings to a real visual novel engine going here. But right now, as soon as Raylene's created, one more thing. She's made visible immediately. Maybe I want to create the character, but not have it visible yet. So let's make a quick getSet variable called enabled that will either turn her off or on. If we just want to check her status, then return whether the root was active in the scene or not. If we want to set her status, then set the root's active status to the value we send through, be it true or false. Now when we create a new character, make an optional boolean to enable or disable the character on start. And I don't think I need to tell anyone how to do this one. So that gives us the option to create and hide, or create and show a character, which is much better than not having that option at all. Since we create through the manager, go in there and follow along with me to make sure we pass through the enable status when a character is made. I'll just set the bool up here in getCharacter, so if it doesn't exist, then it'll create it and take this variable so it knows whether to enable it or not. And then down here, where we go to create the character, let's also put that variable in as well. And where we say new character, since it needs that variable, well, it doesn't need it, but we'll pass in what we have for it. Same thing for when we call it, if the character doesn't exist. Now back in my testing script, I'll create Raylene, but I'll hide her right off the bat. And Raylene is here. You can see her object outline, but she's disabled. Consequently, when we try to make her speak in a disabled state, only her dialogue is shown, but she may as well be a ghost because we can't see her. So in her save function, I want to make sure she's enabled anytime she goes to speak. So if enabled is false, then set enabled to true. And that'll just enable her whenever she goes to speak. So now she should be disabled on start, and I click the button to make her speak, and there she is. Now this video is getting pretty long, but we're almost done, guys, I promise. As you remember, we've got both override and additive dialogue, so we need to allow Raylene to use both methods through this say command. So once again, let's make an optional boolean parameter with a value of false as to whether this should add or override the previous text. If it's true, then we just use dialog.say add instead of dialog.say. And that's it for this episode. I really don't like going this long, but we had a lot to cover, and there's still a lot more. Next episode, we're continuing with our characters where we'll be making them move on the screen. If you liked the video, please give it a thumbs up. Your awesomeness will skyrocket 13%, I promise you that. Also, if you haven't already, please subscribe to the channel and get ready for a whole lot more. Just let me know what you think of the series so far. If you have any suggestions, feedback, or things you'd like to see, please let me know because I'm always open to new ideas. So, until next time, this is Stellar Studio wishing you a happy week and happy coding.